Hi guys, today I'm gonna present PasShield, protecting web password using TLS. And this is our team member. We want to say thank you to our supervisor, Professor Alaka, for his guidance, support, and expertise throughout our study. I will talk about the background first. We use term password to refer to any user memorized authentication secret. Passwords are generally weak secrets which are often reused across multiple servers. The diagram below is a generalized model of password-based authentication system. With the assistance of client-side software like a web browser, a user sends his user ID and password to a server over a secret channel such as TLS. And based on this, the server makes authentication decision. Although real systems are more complicated, but they can all be logically represented as this model. Here are the potential threats to it, including phishing attacks that a user discloses a password directly to adversary under the mistaken impression that the password is being sent to an intended service, or stolen password database, that the information about the password or the password itself is leaked from the server. The third one is server compromise, like web server memory snooping. Like any comprehensive solution for protecting passwords must defend against all those different attack avenues. We introduced PasShield, a comprehensive system designed to safeguard password confidentiality in web services. PasShield is based on the concept of safekeeper, but implemented using the more model Eagle platform. PasShield is capable of defending against both phishing and password database theft, even in case of real service. PasShield has two main parts. The first one is server-side password protection service, and the second one is client-side password protection service. So the client-side assurance mechanism that allows user to easily determine if it's safe to enter passwords on the web page. For the server side, the server is further safeguarded by the server-side TEE, which is a trust execution environment that isolates it from all other software on the server. To prevent online guessing attacks, PasShield features a unique rent limiting mechanism that frontal such attacks on a real server. This diagram shows the basic of PasShield, which I will explain from the user's perspective for ease of understanding. So the first thing user wants to do is to check the remote attestation by the PasShield's browser extension. So what is the remote attestation? To securely transmit a user password, the PasShield browser must correctly authenticate the PasShield password protection service running inside a TEE while remote attestation. So how it works? PasShield can use Microsoft Azure attestation for remote attestation. The process involves the server generating a self-signed certification and a report, which are sent to the Azure attestation provider for validation. If successful, a JSON web token is returned to the server, which is used to establish secure TLS connection with the client. Thankfully, Eagle's API provides helpful functions for simplifying the remote attestation process. When the remote attestation is done, you will see it on the left. When it is not detect the TE, it will show the thing on the right. The second thing that user will do is just sending the password. And so we're gonna talking about the starting password. The password storage process is simple yet secure. When a user enters their password, PasShield generates a random cells value and combines it with the user's password. The resulting string is then encrypted by using HMAC, which provides a strong layer of encryption that is difficult to break. The resulting HMAC value, along with the salt value and the user's username, is then stored in the database. The use of HMAC encryption and the salting provides two key benefits. The first one is ensures that passwords are stored in encrypted formats that is highly resistant to attacks. Even if an attacker gains access to the database, they will not be able to easily decode the passwords. Second, salting adds additional layer to protection the encryption process, making it even more difficult for attacker to decode the passwords. The last function of our project is really limited. The main part is it can prevent the brute force attacks on password services. At the end, I want to say thank you to our surprise Professor Alaka. Thank you for the tolerance and the patience with us. Thank you so much.